Okay. Hello. Hi, everybody.
Hello there.
Hi, Georgia, through the wall.
Hey, Nicole, through the wall.
Welcome to Learning Space, everybody. So on today's show, it is April 1st when we're broadcasting. So April Fool's Day, traditionally, when, people will play pranks or jokes on each other or on the world at large.
Sure.
And yeah, if you're like me, April Fool's Day is kind of old. Uh, kind of done with it.
Seen it all, done it all already. You're too young for that. Stop that.
Well, it's not. It's okay. Me personally, I'm terrible at coming up with funny pranks. Um,
It can be an art.
it can be an art.
Fine line between funny prank and out-and-out disaster. So
Yes.
one has to be careful.
I was part of a prank that I was rather proud of that we pulled back when Google bombing was still a thing you could do. You could specifically make a link appear first on a Google search. I think it's a bit harder to do. They've changed the algorithm. And so for a time, when you Googled awful waste of space, you actually got the webpage of the Very Large Array in New Mexico. Any of you who've watched the movie Contact probably think that's either terrible or hilarious. And so that was one that I was a part of. That wasn't a complete disaster. But after a while, I feel like April Fool's pranks are either like they come out mean. I've had a couple of friends email me today with some pranks their boss tried to pull that was just mean. And it's even a little predictable. The last few years, the April Fool's Day has been a day for the internet to be incredibly self-aware of its own ridiculousness and just kind of done with it. So.
Yeah, I don't know. It was never quite my favorite holiday. A lot of, I think, because as a teacher, you always have to be on your guard on that particular day. If not for yourself, just for other, student-to-student kind of pranks and issues. So my students were always very nice to me, I have to say. I don't think I was
Lucky
ever the victim of any kind of big practical joke. There was certainly, elevated silliness going on in class, which is always okay.
Yeah.
And that's fine, This morning we had our director here at the STEM Center, right, walking up and down the hall singing, which is cool.
I'm pretty sure that wasn't April Fool's Day related.
No, but that's all right.
But now that song is stuck in my head. So if she meant to pull that prank, that is totally the Everything Is Awesome song from the Lego Movie. If you haven't seen the Lego Movie, it's quite fun. But yeah, our director was walking up and down the hallway singing that this morning, and it's stuck in my head now. It's a fabulous song, so it's okay.
It is okay. So, but sometimes it's just, it is fun, but you do have to kind of be careful. And then, like you say, sometimes things just kind of get old, and you just wonder, what else is there? Can we do anything different?
Yes.
Make it better.
I've seen a couple of comments from you guys, so before we get into the meat of the program, I want to remind you guys that you can comment and ask questions and take part in the live show using the Q&A app. So click where it says Q&A, join the conversation, and you can do that. So we have hello from Guido, who also admits he hasn't seen a decent April Fool's joke all day. That is sad. Although I think the only thing I've really enjoyed today is those of you who are 90s kids, 80s, 90s kids, Homestar Runner, Strong Bad emails. There's a new one today. So go check that out. That was kind of funny because
that is, but that's all right.
So yeah, Homestar Runner did a good job. That's the only thing I've seen all day that I really enjoyed. Nancy says hello. Michael Jobin says exclamation point. And as Guido points out, daylight savings is now started in Europe, so we're back on the same time for you guys because we had our daylight savings.
All right, I know we're so early. Gosh.
We are. I'm mostly okay with that because I dislike mornings.
Well, I've been enjoying it, I have to admit, too. I'm not a big fan of daylight savings time, but I don't like that switching thing, but the weather's been so good here that I have really enjoyed going home and still having some light at the end of the day to enjoy outdoor stuff. So I'm all for it right now.
That is always
For
nice.
now.
So today we're putting a positive spin on April Fool's Day. Oh, sorry, I have one more comment from Nancy. What's really sad is when you can't tell if something is a joke or reality. That's the problem with the entire internet. It's like you can't trust anything, more so than usual.
Yes,
So
yeah, more than usual. I was just thinking that this morning too, looking at emails coming in, and I'm thinking, okay, I have to be careful and not get taken by
yeah,
of these, maybe. But sometimes you just don't know.
yeah.
And that is the internet.
And Adam Synergy says hi. It's apparently still daylight savings has not hit in England yet, so the UK is going to catch up with the rest of Europe this weekend.
Oh, summertime will be.
Daylight savings is ridiculous. Okay, so what we're going to talk about today's show, we're not going to talk about daylight savings or the motion of the sun throughout the sky. I have a whole class that I taught about that right before the equinox, actually, in my class here.
Oh, cool.
But we are going to take a positive spin on April Fool's Day and talk a little bit about this concept of discrepant events. It's a term I had never heard until I started working here at the STEM Center at SIUE, talking with all the science educators here, as a way of using something unusual or unpredictable or not as it seems to be to introduce a science concept. So we have some examples we're going to go through, but first, like Georgia, to talk a little bit about discrepant events, what it is, and how you might use it in the classroom or in an informal educational experience.
Sure, yeah. These have actually been around for a long time. I never really heard of them being termed discrepant events either, but I had always heard of, you have some sort of interesting or unusual activity that you pull out at the start of a lesson to at least get your class's attention. So at least, say, hey, woo, look at this weird thing over here, and so, ideally all students' eyes turn towards you, and then you can proceed on with the lesson. And so that was always a really important part of a lesson plan, whatever you want to call it. So, but it's actually, you can think of it more broadly than that. There's actually really good psychological educational reason for having a discrepant event either at the beginning or at the core, the focus of your lesson. And what it's basically doing is sort of giving the brain sort of a, what the heck's going on here kind of moment. It's creating some what they call cognitive dissonance or cognitive disequilibrium, where you're kind of taken by surprise by something that just doesn't quite make sense to you, and it's just not what you expected. So it can be very helpful in dealing with misconceptions, alternate conceptions, whatever you want to call them. So something that your students have been thinking, for whatever reason, for a long time, and maybe scientifically it's not quite the proper way to think about it. So a great way to sort of start modifying that perception or that concept is to, get their attention, confuse them a little bit, make them a little uneasy, so that they really are motivated to figure out what in the world is going on. I always thought it was this, but now, I'm seeing this weird thing in front of me, and all this time, I don't think, I've really understood what's going on. And so then, what is going on? You create that desire to know. And so then you can get into, depending on if it's more of a formal situation in school or if you're out at a science center, you can use these really anywhere, or even if you're just a parent talking with your child and it's one of those little teachable moment kind of things, by questioning and maybe going through an activity together, or just giving a child something to kind of play around with this for a minute, see if you can figure out what's actually going on. That's a really powerful learning experience. And so, because it's very experiential, you're engaged, it's hands-on a lot of the time. You can play around with it. A lot of these discrepant events they're really just kind of toys, and you want to play around and figure out what's going on. But then if you want to, you can question students, question people, and really sort of guide them into figuring out, what is the science that's going on that's underlying this weird thing. So they have a lot of great things about them that work really well in classrooms or with scouting groups or wherever you are and you want people to learn something. But at the core is really that this idea of cognitive dissonance, that something you've already or always thought about just isn't making sense to you anymore, and your brain you have to figure it out. It's like a puzzle.
Yeah.
So there's a lot of different ways to do it. We have some things, like you just said, we've got some activities, some little toys here, but this can be something as simple as like a picture that you show people that's weird and doesn't make sense. And so then, that process starts going in people's brains. Why, what's wrong with this? I have to figure this out.
Some of it, a lot of it is in the presentation. You can build up the drama of something, or you can even, in a way, use misdirection the way a magician might. I don't know if I want to give this one away. The candle one?
Yeah.
The eating of the candle? I don't want to give that one away. But generally...
Well, so some of them are actually out and out tricks, more like April Fool's Day, which, here I'm deliberately doing something up in front of the classroom and it looks obviously like, A, but haha, it's really not A, it's B, because there's some things going on that there's no way you could have really known. And so there's an element of, misguidance or trickery there, which, you have to, again, like April Fool's jokes, you have to be kind of careful so that you don't really get people frustrated and annoyed that, oh, well, of course, how could I figure that out? It was all a trick. So, but yes, that's an element of some of these.
Yeah, so the one I'm going to give the introduction to, but not give you the punchline. Because I've seen Kathy Costello do this. She was one of our CosmoQuest educational consultants and lesson plan creators, and I watched her do this in front of a teacher PD, and I was like,
oh, that's cool, because see, I've never actually seen this done.
Oh, I've seen her do it, and I bugged her. She won't give it away. She'll do it for her students when she was teaching education majors here, but wouldn't give them the secret, and they had to either figure it out, or she would give it to them, like, when they were doing their own teacher experiences. But she would hold up, it was about the nature of science and assumptions and observations, and she'd hold up what looked like a candle. It's like a little off-white wax candle, and light it, and she said you could build up the drama and talk about the nature of science, and she's holding this candle the whole time, and then she eats it. So you see someone take a bite out of a lit candle.
Does she blow it out before she eats it?
I don't remember if she blows it out first or if she just goes for it. I feel like it was more dramatic if she didn't, but I can't quite remember. And yes, the secret, I'm not going to reveal the secret behind that. I'm sure you could find that on your own if you really want to. But it really drives home the point of be careful what your assumptions are, because your observations are limited. In this case, they're only allowed to look at what she's holding. So yeah, that one I didn't find the materials for that in time, so I'm not gonna do that. And I totally would have blown it out first because I'm not practiced enough with that one to just eat it.
Yeah, so that's a great example of one. Yeah, that's kind of a trick, but it really gets your attention. Yeah. And at first, it's just getting your attention because, you're in the class and the teacher's holding up a candle and we're observing the candle, and that's cool. But then, you're really thrown when you start to eat the candle. So then you realize that, what I was looking at wasn't the whole picture. Yeah. So you can talk about science and that how you gather information, you observe a lot of times, you're looking for patterns and things, and then, maybe you think you've got, the idea of what's going on, you think you've got some sort of beginning of a theory, and then, as more information comes in later, you may have to modify what you originally thought was, really the right answer for something. So, you can really use these to model how science works, how scientists think, how more information coming in can totally change what you thought was going on, and it's just fun.
Yeah. So, another example along those lines are the NOS tubes, the Nature of Science tubes. NOS is what we call them here. So yeah, we each have one of these, and these are, so I've actually given us, so one of them is labeled yellow, yours is labeled white, there are some that are unlabeled. That's a key for the people who made them. And it's, as you see, you've got this tube and it's covered in duct tape, so you can't see what's happening on the inside. But there are several holes with string coming out of them with knots and stuff. So pull a string. Yeah, so pull a string and see what happens.
I don't even know if you can see this. Probably can't see all this.
Yeah, I think we both got to back up a little.
Wait, all right.
Yeah.
Wait, now I got to go down.
Yeah.
All right. Woo.
Pull that one, and your challenge is to figure out what's going on inside.
Because again, what you think is going to happen is not what happens.
Not necessarily what happens, yeah.
So your brain...
Oh, not one. That one's driving me nuts, okay? Like, what's that? And this demonstrates the nature of science in that you can't always know what's happening inside the tube. You don't always know exactly what's happening in the inner workings of things, but you can test stuff on the outside and see what effect that's weird. See what effect that has. I'm like, wait, it's not doing what I expected.
Uh-oh. Discrepant event?
No. Wait, what? Okay. So you're figuring out how the strings are interacting inside the tube. And so we have 3 different types of these, and the color tells us we have a key, of course, so you don't have to pull it apart to see what's inside, but then you can, actually finish, if your students are curious, you could do 2 things. You could never tell them what it's like inside. That's a little bit more like reality. But sometimes they really want to know what's inside, and you can show the diagram of how it was made. And I'm pretty sure these are just Pringles cans with the chips.
Like Pringles cans to me, totally.
Yeah, and then string and duct tape and various other bits.
So have you used these, Nicole, or seen used in a class?
We put some of these out for the students to explore in my class this semester. Mm-hmm. So I'm teaching physics, earth science, and inquiry-based projects for elementary education majors here at SIUE, Southern Illinois University, Edwardsville. So this was one way we talked about the nature of science. I put out all of these, actually I didn't, Colin Wilson, our resource center manager, put out all of these fun activities for them to explore on their own in the resource center. So we talked about these and like all these fairly cheap little things that you can make yourself, or if you're close to a resource center like ours, just borrow from us. For example, I actually filled out the form to borrow all these things for like 2 hours.
I'm just wondering if students have tried to actually diagram what they think is going on inside of those tubes.
We didn't do
that
this one.
Into it.
We didn't do this one specifically, but we have another one that I used last semester, and I'll use again at the end of this semester. They explore how magnets work, and they're given a box that's completely opaque, and they have to determine what's inside the box.
Yeah.
Using magnets, and this isn't giving anything away, but there's a mixture of metal things inside as well as more magnets, and they have to diagram out what they look like, and then I get to show them. I don't let them rip it apart, but I do have diagrams that show them which one is which and how close they've gotten to the answer. So we do it in the magnetism activity, which they seem to enjoy. So they're really excited when they see the answer that usually matches what they've gotten.
So you mentioned in your class you had a bunch of these out and your students were kind of playing with them, right? Mm-hmm. So that is a great idea for any teacher. A lot of teachers have stations. They have things out in their classroom so that students that finish work early or just want to do something different, they can go off and they can read a book or they can play with something, do something at a center or on a computer. And if you go on the internet, I was doing this morning, there are millions of sites with just lists of these things, one seeming to be just as good as the other because there's no end to these things. Get a big list, construct a bunch of these yourself. Some of them require equipment and things, but others are very simple, really, and might just take a little time and some stuff from the grocery store, and you can make a bunch of these yourself, put them out in your classroom, and you know, they're there for students to puzzle over and play with when they have extra time. And so it doesn't even have to be part of a formal lesson, although they're great for that too.
Or you can also have them as extra credit activities. Figure out what's inside the canister. You know, it could be an extra credit activity.
Yep.
I've seen a bunch. My chemistry professor in college was very good at using these things. I do not feel confident in my own ability with chemicals and safety in this office to do any of them. There's some list of chemistry-specific ones. Also, that particular professor, Dr. Franz, rest in peace, it was his last semester teaching before he retired, so he basically blew up anything he could. Because what are they going to do, fire him?
Go out with a bang.
If you're doing chemistry, there's a lot of really amazing stuff you can do safely in a laboratory setting with lab goggles and all that.
Yes, exactly. Totally. Yes, safety is key if you're going to do that.
Yeah. So we don't have any of those because I'm not very good with chemicals.
No, in fact, one of the things I was looking at, I don't remember what document this was, but it had a list, and some of them were using chemicals and things like that. So they had some safety, you know, tips, and one of them was, of course, read the directions and follow the directions, and then the other one was, when in doubt, use the smallest amount of chemical versus a larger amount, if you're just not sure. But better to be sure.
And test your things. If you don't test, I mean, this works with any demo, right? Test your stuff before you bring it to class, because then you bring it to class and it doesn't work and you look silly and you've got this awkward silence to fill before you can move on with the lesson.
Yes, that's kind of a discrepant event in itself, but not in a good way.
Not in a good way. We've got another one, which is a very popular science toy here. So it's a little clear container with some twisty bits and bulbs and a red liquid inside. And so what I can do is put my hand over the bottom here. Observe.
The liquid is
there we go.
Going up.
Liquid goes up, and it actually appears to be bubbling and boiling at the top.
Oh, now I see that.
Yeah. So this is typically called a hand boiler. And it's odd because we're used to seeing water boil at 100 degrees, and my hands are not that warm, right? This is not a stovetop. This is my hands. You can also hold it, and most of that liquid kind of stays there. A little bit's dripping down, but if I hold the top bulb, it comes down.
And it's bubbling down at the bottom also?
Yep, bubbling a little bit at the bottom. You can see that. So this is a very, so do you, I don't know if you guys have already learned how these work or want to guess how this guy works, but it's basically showing that when you heat up air, you heat up a gas, it will expand, and in a confined space like this, it's expanding and popping its way into this bulb, and it looks like it's boiling. It's not really. It's just the expanded air bubbles coming up through. I think also a trick to this is I didn't tell you what liquid this is, although I did mention that water boils at 100 degrees Celsius. There's a little bit of misdirection. This actually has, let's see, this actually has ethyl alcohol, which is flammable. Caution, flammable. Don't set fire to it.
And what's the gas in there? Is there something special about that too, or is it just?
I don't think there's anything special about the gas, but I might be wrong.
Okay.
But it may be just that a different density liquid than water makes it work more easily with ethyl alcohol than it would with water.
Yeah.
So it's not magic; it's science. Boom.
But it also shows how important it is to get those assumptions that students have and bring into the classroom out into the open, because, like you say, we assume, oh, if a liquid is bubbling, it must be really hot. It must be, 100 or 212 for us older folks, and and that's not all. So this is a new, something new, something surprising that's making everybody go, whoa, what the heck's going on there? And sometimes, like you say, so we're assuming maybe it's water in there, but maybe it's not water, and that's a good thing to think about. Is it just air in there, or is it some special gas? It's always, these are questions, right, that you can get in the habit of asking when you come in to contact with something that's puzzling you and it's not what you expect. So start going through this nice scientific process of asking questions, gathering more information, talking with somebody else about it. Another nice thing about these is that they can be used as small little group activities or even a dialogue between a teacher and a whole class if you are kind of doing it as a demo. But get that dialogue going back and forth, because it's often, in talking out your ideas with somebody else and then listening to someone else's ideas and trying to come to some sort of answer through that process, that is really important for learning and for science. So that is involved too.
I had a thing and it left my brain again. So bad at that.
What?
I'm like, I thought of a thing I could add on to George's when I'm listening to Imogen.
I was going to add that a lot of these little activities, a lot of them seem to involve like a liquid, which may or may not be water, or air somehow, because, air, we don't usually think too much about it. It's always there. We can't really see it unless it's doing something really amazing, but it's just always there. So when there's air as a part of these activities, usually through pressure of some sort, that really can take people by surprise and go, wow, I didn't think of that before.
That reminds me of, it was an episode of Mythbusters that was based on a YouTube video. The YouTube video had a fish tank that was empty, and there was like a little tinfoil boat floating like in the middle of the fish tank, and it was like invisible water. And again, that's kind of a trick, a cool thing, a discrepant event. Like, why is this boat floating in the middle of this fish tank? It looks like it has nothing in it. Yeah. No, water, they did not actually find invisible water, but Mythbusters did a great job of showing that you can use a clear gas that's more dense than the air around us, the mixture of gases around us, and you can float a little tinfoil boat on this gas. I forget what gas they used, but just as a less dense gas like helium can make your voice go higher, this more dense gas can actually make your voice go lower. It's not recommended that you do that because, once again, my great chemistry professor, Dr. Franz, did that once, and apparently it went badly because the gas settles in your lungs too. When you breathe it. Whereas you can breathe in helium and make the voice squeak and it's funny, but it eventually fades because the helium escapes. If you do this in one of these gases that's more dense than air, it has the potential to settle it. I don't think this happened to Adam Savage on the show, but it happened to my chemistry professor. The gas can settle in your lungs. Or and it was hard for him to breathe. So, and he had a TA standing by to help him out, and so he did quickly, like, had the TA help him get into a handstand to get the gas to go.
Oh wow! Good.
So don't do that. But if you have access to that gas, you can make a little tinfoil boat float on it, and it looks cool. So that reminded me of that.
So that makes a great story, but don't try it.
Yeah, that's fun. Don't try it at home. The other one I thought I just remembered, because we're talking about the hand boiler, I've discovered that I can make a discrepant event happen with dry ice if I don't tell people what it is in the first place. I'll put so usually I'm doing a demo with a comment or something. And so I'll plunk a bit of dry ice in my water bottle, for example, and what happens, right? It starts bubbling. It looks like it's boiling. And so you show that to somebody, I show that to kids, and they're like, oh, that must be hot. It looks like it's boiling. Or liquid nitrogen, that's another one. They see it sitting in a cup or in a dewar, and it's boiling. And they're like, that must be really hot. And you can have them wave their hand over it and feel the gas coming off of it. And it's super cold in both cases. So that's another discrepant event, is like, oh, you think it must be hot if it's boiling. Well, put your hand near it. Don't touch it. Put your hand near it. With dry ice, it's easy because you can usually see that cloudy carbon dioxide gas and carbon dioxide water vapor mixture gas. You can actually see that and wave your hand through that stuff that looks like smoke, but it's really cold. And the same thing with liquid nitrogen. You can kind of feel right above it. It's actually really, really cold, even though it's it is boiling. It is actually boiling. Just that
Yeah, there's a lot of dissonance there.
Yeah. If you don't realize it's liquid nitrogen, first of all, I hope you're nowhere near it. Second of all, it looks like boiling water if left to its own devices.
Awesome. So yeah, so these things are really, they're very multisensory, so which really helps with, remembering them about, 20 years later,
Yeah.
Which really some of these things I remember from my own teaching courses. I was lucky, I had good science teachers, and I had, even when I was learning to teach, I had good education science teachers, and they would bring these weird things in, and you remember them forever because, you see it, you can feel it, and again, so the dissonance is happening, when you're looking at it, that's weird, and then, feeling it, no, that's not what I expected to feel, right? And so it just hits you on all these levels, and it's really powerful.
So another sort of related discrepant event is this bottle. I'm shaking off camera.
So what is it?
This bottle here, I'm not going to tell you the name of it. You've got a bunch of beads, those little pony beads in it, and some clear liquid. Shake it, and what do you think is going to happen when I stop shaking, for example?
I don't know, but I'm already wondering, is the liquid water or is it something else? And
so
let's see, exactly what are the little bead things made out of?
So we have the white beads at the top, the blue beads at the bottom. But if you leave it and watch what's happening.
Slowly.
Yeah, they're slowly coming together. I remember being so excited about this when Colin showed me. I blurted out what was going on without giving my students a chance to think about it. I am also a child excited about science. And yeah, and then when I found it on the shelf, it was sitting there like this. So what do you think is going on there, Georgia?
Awesome. I think it's not water.
One of them's water, so it's actually called a polydensity bottle. There are two different liquids of two different densities. I don't remember what they all are.
Oh, so that's another trick. Two liquids.
I kind of want to smell. No, I'm not gonna do that. Yeah, so there's two different liquids in here. I think one is water, and the other one, again, it may be ethyl alcohol. I've been told not to open it and sniff it. What I do, and I'm like, oh, I don't know what this is, and they're like, stop. Waft. I guess you could waft it, right? That's what proper.
I think that's acceptable.
Lab scientists do. Yeah, so there's two different liquids in here with two different densities, and these beads are also made of different materials, so they have different densities as well.
I knew it.
Yeah, so that's why those blue ones separate out from the white ones, and then when you're shipping it up, the mixture of the two liquids is in the middle density of the beads, but then the liquids will actually separate, and then you get those to come together. So we've got polydensity bottles of all shapes and sizes here in the Resource Center with different colored beads in them. I don't think these are the UV sensitive beads, but I always think that they look like them.
Mm-hmm.
So yeah, you can't really see, may not be able to see well on the camera, but you can see that this middle liquid is all full of bubbles, so it's not fully mixed, and it's separating out into the top and the bottom one. So that's a fun one. You get to figure out what's going on there. I will let that settle elsewhere.
So people can make those. And I've seen some and heard about some really great teacher workshops where not only are the teachers learning science because that's part of why they're there, but they are being helped to construct some of these cute little toy things themselves. And so that's just another layer of, really learning what's going on there. So not just to be sort of an observer, but to actually, figure out how can I make this and what do I have to do to put it together to make sure it all happens the way, it's supposed to happen, to my next audience. And that is a really cool way to sort of structure some learning for teachers. You could do it for kids too, again, but, safety. You have to be careful about what kinds of things you're helping them construct. But certainly, you could get your younger kids, your younger students to make up their own discrepant events and get some powerful learning going that way.
Don't mind me moving things around.
That's okay.
Okay. So there's a couple more that I wanted to show that we need to really see the table for. Oops, turn that back. Hi. So this is an odd angle. So this one here, and again, this is another one that's better served as a tactile experience probably than just watching on a video. But I've got these two rubber balls, and rubber balls are typically bouncy balls, and so I could take them over to the table, and you can compare them as I drop them. Wah wah.
Do it again.
So these two, oh geez, went under the desk. So these two seemingly identical rubber balls here.
They look the same.
Hmm?
I was gonna say they look the same. Absolutely.
They look the same. They mostly feel they feel the same. And like they don't feel the same to me because I've worked with them before. But one is made of an elastic rubber and one is made of a material that is not nearly as elastic. But they're the same weight, almost same weight, same color, same shape. Everything else seems the same about them. But when you drop them, one of them bounces and one of them doesn't. So that's again challenging your assumption that just because something looks similar doesn't mean it's exactly the same. And the name we have for these sets, at least, is called the Happy Sad Ball. Because one of them is happy and one of them is not.
I know. It's kind of a test for which you think is which.
Yeah.
I don't know.
I think that's one's the happy one.
I don't want to assume which one is the happy one and which one is the sad.
The sad one? Do you think the happy one is the calm one and the sad one's like...
Yeah, never seen
that could work too.
But they're different, yeah.
You could, I think they're also called like decision balls because like you could flip a coin, get heads or tails. You could pick one at random, and whether it bounces or not is your, it sounds...
Great idea.
Yeah, it's a little bit more complicated than just flipping a coin that you probably already have, but that's another use for them. And while we have bouncy balls, let's get back to the... Actually, I'm going to turn my lower third off for a sec, because that's restricting my space here. So I've got some more bouncy balls, rubber bouncy balls. And so you can watch them, see how high they each bounce. Woo! Can you see that? So they're kind of similar in how high they bounce when they're dropped. So bounce, bounce, bounce. Ah! And they look like they're bouncing all over the place, but they're not too crazy. Here's another one that has a stick through it, which will become apparent why you have that in a second. So drop all the balls together. Ah! And they're all over my office. Hang on. Rolling off of desks. Okay. So you have them, they bounce to a height of about here. I'm still missing one. Oh well, it'll still work. But if you put them together, so what do you think is going to happen if you put them together and drop them all on top of each other? Let me fix this one.
I would say they're not going to bounce as high.
Not going to bounce as high, so we can drop this from this height and see how high they bounce. Oops, or I could completely miss. Hang on, let me see if I can find the green one for a second. I lost one. Yeah, the thing about doing your demos ahead of time is this one works really well, but if you have a cluttered space, you can easily lose one of them. So let's try this anyway. Ah! It's not quite working without the other one. That makes me sad.
That's okay.
Okay, so if you've ever seen this done well before without somebody who lost the pieces along the way, you can do this with a basketball and a ping pong ball. For example, if you can line them up well. This one is cool because it has a stick attached to the biggest ball, and it bounces, so you can try and keep them all vertical when it goes. Let me see if... Whee! Oh, there we go. Ew, it went in the garbage.
Something else to think about.
I don't know if you guys actually saw that, but finally got it to...
I've read about this with a basketball and a ping pong ball.
Yeah, basketball and ping pong ball is one way to do it, but this is a little kit version of it. Ew. What happened, if you couldn't see that, is the red ball went way out of frame and then down into my garbage can. So what actually happens is that when you have these things stacked up and they hit the biggest one, they transfer energy up to the smallest one. The smallest one goes flying off to a higher distance. And when this kit is actually all together, we have busted into the ceiling many times with these bouncy balls that otherwise only bounce like a foot or so. So yeah, they could actually, have it complete, find the missing one, it'll into our ceiling, which is not entirely solid, which always makes for fun times. So again, this is a tough one because when it works, it's awesome. This little red ball shoots off and is just gone. And when it doesn't work, it's really sad because you're going, wait, where did it go? Yeah. So, but if you can practice it and do it with a basketball and a ping pong ball, that tends to work pretty well. That ping pong ball will go flying off into your classroom or wherever you're doing that.
Yeah, when I was looking on the internet to try to find something a little different to show today or talk about today, and a lot of them are so dependent on having things set up just the right way. So you definitely want to try it ahead of time. Try it a few times ahead of time because sometimes it's just, this thing is not set up right or not in line with this, and so then it's kind of like a magic trick that just falls apart and doesn't really happen. So
yeah, bad magic.
And then you're stuck sort of explaining what should have happened or could have happened, but so sometimes
finding a video of someone who's done it well is okay if you're really in that situation. Yeah, like a badly done magic trick is just so extra bad because you can see it happening. You're like, oh.
I know. You can still learn from that.
And that's what you guys just saw me do. But we particularly like this one in astronomy because it's talking about the momentum transfer all the way up to the tiny ball, which is the tiniest mass. So we use it in physics class, but then in astronomy class we use it to demonstrate how all the layers that collapse down onto the core of a star bounce back out during a supernova. So I call this the Supernova Demo. I forget what it's actually called in the lab in our resource center. Sure.
No, I actually haven't seen that particular one before. So.
Oh really? Yeah, I love this one.
No, I read about basketball and ping pong ball, but.
Yeah. Now I gotta find the green one before.
Fancier one. Totally.
So those are the examples of discrepant events. So of course, if you are listening to the only version of this, you're missing out. At least on my failures. But hopefully we've described this a little bit, and you can check out the video if you can, or look up what some of these are. And
there are lots of lists on the internet. Nicole, you mentioned YouTube. Of course, YouTube has got tons of videos on these because most of them are pretty visual. So. It's great, and it's kind of nice to see a demo of somebody else doing it first before you decide if you want to go ahead and try it, in front of an audience. So there are lots of places to see examples and get big lists of these things. But the NSTA, the National Science Teachers Association here in the U.S., they have lots of great books, but they have a book, actually a series of books, all about discrepant events. It's called Brain-Powered Science, and so again, you can just Google that, and that has lists, but also descriptions, a little bit about the theory behind why these are important, the cognitive dissonance ideas, share these with questions. So if you're in a formal education environment, you're a teacher, and you want to have these be sort of the core of an entire lesson, how, the importance of what questions to ask your students to really guide them to figuring it out. So you can make so much more out of these than just, they're great just as sort of, hey, this is cool and weird and what do you think's going on? If you get some questions structured ahead of time so you can guide them really to coming up with some of the answers. it can be the focus of an entire lesson. And so there are a lot of nice resources out there for teachers that help you do that. So you can really build on the fun of the event itself, or ways to set these things up as independent activities for extra credit, or things when people need something else to do. Those are all good ways to use these things.
So I put the link to the Brain-Powered Science series on the comments, and I'll add that to the show notes for the YouTube video. Yeah, there's Brain-Powered Science, more Brain-Powered Science, and more Brain-Powered Science.
And that's not the only one, I'm sure.
Even more.
One of the first ones that came up when I was looking.
But they have some free chapters available, and connection, internet links, and then they've also got correlations to the next generation science standards and some other standards I don't know the acronyms of. So that can actually use that in the classroom for a particular lesson.
Yeah. And again, if you are a teacher or a parent or anything like that, you're talking with young people about science or trying to teach people science, these kinds of things can come around, from all different parts of life. It doesn't have to be an activity or a toy. I think I'm losing my voice. That's weird. It can be something in a movie. It can be a scene on a TV show that just, that's weird. What was going on there? It can be something you read. It can be something you see, like in a museum, outside even, something out in nature. So anytime, you notice something that makes you stop and take a second look, basically, what is going on there, that is something you can, bring into your classroom, bring to your next, teen science cafe event or whatever it is you're doing where you're interacting with people, and you want to share with them, how exciting science is, and, how you can think about things differently, learn to have those questions in your head, that when something is surprising, now suddenly the wheels start to turn in your brain, right? So you're going to start to think, well, maybe it's not what I've always thought. What kind of liquid is that? What is that yellow stuff? I'm assuming maybe it's this, but really, maybe it's not. And so you start to get that mindset, that sort of scientific habit of mind where you're questioning things a lot and not just assuming something and running with it. That you can bring into your teaching and your presentations, all the time, just by stopping and asking some questions. So
I like to think of it as embracing your cognitive dissonance.
Yeah.
Because you're going to learn something from it, and not just in science or observing in everyday life. It could be something as complicated as your own philosophy of being in life and how society works, and that may
you can question
cognitive dissonance. Yes. You're questioning everything, and that's okay. I think that's an important part of learning about anything.
Yeah, I know. Well, it happened to me last night and this morning, because I learned a whole bunch of new stuff today about comets and asteroids, thanks to my friend Nicole. Because I had this I shouldn't say horrible. I just had this wild instance of cognitive dissonance last night as I was reading through something, and it was something about dwarf planets and how they are or could be considered large, round asteroids and comets, right? And that's all you need to know. But I read that and I thought, wait a minute, no, that's not right. Aren't comets the cute little things with the tails, and they come in, and I knew the tail always points away from the sun, right? And I had this idea in my head of a comet that I always thought I knew, and this was what a comet was. And then I ran into this other, again, it wasn't even a toy or anything, it was just a line in something I was reading, and that was enough to just, hold the phone, stop the presses. My brain just sort of broke right there, and, I'm texting Nicole, hey.
Yeah, you're texting me last
busy. Sorry.
1 p.m.
So, and, I learned that comments are so much more than I ever thought before, which is, it's great. But
And yes, and we got to discuss that. No, really,
we were
the system of classifying things in the solar system really is that screwed up.
But it just goes to show that, you know, you see these cognitive, sorry, boy, my brain is gone today. You see these discrepant events a lot, and they're toys, and yeah, and those are great, and they could be demos, you know, complicated chemical, physical things going on, but you know, as a teacher or any kind of science educator, you know, get in your own habit of mind of always taking advantage of anything that your students bring up to you, any question, and try to create that sort of discrepant event scenario out of it, you know. Why is this different from everything you always thought you knew? What's weird about it? What's really going on? How can we find out? Let's talk to some other people. Yeah. What do they think? You know, that whole process can get into motion, and you've got your own discrepant event out of almost anything. Mm-hmm. But I admit the toys are fun.
The toys are fun. And I finally found the other ball.
Oh, where was it?
It was like it was in the corner of my office. Behind some posters. I don't know how it rolled over there. But I'm going to try this and hopefully not mess it up the one chance I have. So I'm not going to show the full bounce from the table, but you guys will get an idea of what's happening when I duck for my life. Where'd it go? So the little red ball, again, probably too fast for the frame rate of this camera, sailed up, hit the ceiling at a high velocity, bounced back, and I have no idea where it is. The stick's actually a little bit thicker at the top so these other balls don't get lost. So we actually have an extra bag full of the little red balls.
Oh, all right, good thinking.
I think it actually comes with those extra if you get the, I think Astro Blaster is what it's called. But yeah, so the momentum was from all of these balls was allowed to travel to that one little red one, and I have no idea where it is.
Awesome. Is your ceiling okay?
So yeah, this one's a little more has a bit more structural integrity than the last STEM center we had. I'm pretty sure we actually put holes in that one.
Yeah.
Like you do. So I hope you guys enjoyed that, even if you couldn't quite see all of what happened since it went off the ceiling. It is pretty cool to do in like a large auditorium if you're teaching in a larger space. A little less dangerous when the ceiling is really high. Yeah. Or outside. I wasn't too worried because I'm wearing glasses, but you know, you should probably wear safety goggles or something if you're really serious.
Yeah, you do have to be careful.
So yeah, that's fun. So keep looking for cognitive dissonance and keep looking for discrepant events in your life. You can learn something from them.
I know, that's where the learning happens.
So we've got a couple of comments I wanted to go over. Oh, Nancy says it came down behind me in front of my bookcase, over my right shoulder.
Oh, nice.
Where it rolled after that? Oh, I was standing on it. Look at my foot.
Thanks, Nancy. Wow.
Thanks, Nancy.
Good eye.
Bouncy balls look like planets. They kind of already do look like planets a bit, if you imagine a gas giant. We talked about the eating the candle discrepant event. Gita says it sounds like a Marx Brothers thing. I'm pretty sure Harpo did that in one of their movies. I wonder if he actually ate a candle. He used the one that we've seen. Differentiation, Michael Jobin says, is most important thing that folks can learn to apply to everything in everyday life. He also says similarity is what we are hardwired for, but it often fools us, and that's absolutely true. Looking for what we expect to see could fool us quite a bit. Also want to say we were incorrect on saying that the UK hasn't switched to daylight savings time. They have. Oh. We just had... Apparently we collectively had a time zone fail. Okay. Sorry to you guys in the UK. You did.
Well, right. Welcome to daylight savings time, everybody.
Welcome to daylight savings time, all of Europe. It's fun here. Yeah, I think that's what all we had for today's discussion. Thank you guys for your comments and questions, and
thanks everybody. Yeah, for spending a fun April Fool's Day with us.
Yay! No one got hurt. you know, physically or emotionally. I think it was a success.
Yes. No furniture broke. Ceiling's still up there. It's good.
Building's in one piece, or at least as many pieces as it's supposed to be. So next week, you'll have Pamela Gay on Wednesday, April 8th. Next week, we'll be doing Inspiring Science Education about gas laws, talking about with stars and nebulae. And then the week after that, we'll have our second learning space for April on April 15th. We're looking forward to Edgar Bering and his students from the University of Houston, who have been doing some scientific payloads on balloons experiments. And so they'll be returning from that trip, and he's been tweeting a little bit along the way, which has been really exciting. So they have stayed up all night to get data, literally, and will have some fun experiences to share with us on that episode on April 15th. Other than that, you've got the weekly space hangout on Friday at noon Pacific with Fraser Kane, and Astronomy Cast is at, what time is that at? I think it's also noon Pacific. Yeah, because it's 2 o'clock here.
I was going to say 2 o'clock here, but
so noon Pacific with Pamela Gay and Fraser Kane on Mondays. So also, oh my gosh, the Hangout-a-thon number 3.
Oh.
Is happening. So I think that's going to happen the weekend of April 25th and 26th. So Pamela Gay is putting together 36 hours of astronomy and science, entertainment, and education, partnering with Astronomers Without Borders, because the Global Star Party will also be going on, as it is now Global Astronomy Month.
Ooh,
Marks the beginning of Global Astronomy Month. So you've got the Global Star Party that weekend, so we'll have star parties from around the globe. It'll be the Hangout-a-thon. We're planning at least one learning space segment for that.
Yes.
April 12th, Sunday, is Yuri's Night celebration all over the world. We've got one of our earliest episodes, I think, was with one of the people from Yuri's Night organization, so check that out. We will hopefully be doing one here at the custard stand, as we usually do. I just sent them an email today to see if they will let us set up our telescopes at their custard stand.
They love that. They love that. They, they would like us to do it at both of their locations now.
Oh, really?
Yeah, I'm sure they would. I asked about that one year when I first opened the second custard stand, and I said, well, I don't think we have enough people.
Yeah,
but
that's the one closer to my house.
An idea, yeah.
And that's the one that has a drive-through too. That's the thing, that the other one has a drive-through, so people don't have to get out of their car to look at, to get their custards. They might miss the telescopes unless we stood in front of the car and waved at them. Let's not do that.
Drive-through astronomy.
Drive-through astronomy. Oh my gosh, you could drive up, if the eyepiece was at the right place, you could just drive up and stick your head out.
I know.
Might work. So that's a lot of exciting astronomy stuff happening.
Yeah, amazing. What a month.
Yes. So very cool stuff. And I think that now is everything we have.
I think so.
Awesome. Thank you, Georgia, my co-host of Awesomeness Through the Wall.
This was fun. Go out and find your own discrepant event.
Yes. Go find a discrepant event. Try not to break too many things in the process, except your brain, which is fine, because you can always rebuild it. All right. Thanks for watching, everybody.
Thanks, everyone. We'll see you next time.
Bye.